morning and welcome to our session today. I am Carol here from Sunset Learning Institute. I'm with our specialist, David Santana. David, most welcome and thank you for joining us today.
Hello and welcome, everyone. All right. Hopefully, everybody is able to hear me clearly. My name is David Santana. I'm actually the Vice President of AI Technologies for Sunset Learning. But like most of you here, I'm also an engineer. So one of the things that we're going to do is we're going to delve into enhancing machine learning operations development. I know it's long-winded, right? Of AI model pipelines. And the key topic is using GitHub Copilot. So think of it. We're talking about improving our AI workflows, thus accelerating your software engineering life cycle by accelerating what you might know as a sprint, right? Getting that product to market using generative AI. So thank you, everybody, for joining. And as I talk through this, I'm actually going to stop every now and then, not just to cover some of the slide content and go over my agenda. You'll also see me in real time interact with tools that I will be using, that I will consider that you too should also factor in using in order to what? Augment some business process, because your development of any service, or if you prefer the word solution, is one more business process. And we can accelerate that using generative AI. I know I just keep throwing that word around. You're probably thinking, okay, I've heard about that. That sounds like a Google Gemini, right? A Microsoft Copilot. I'm sure we will elaborate soon enough. All right. First, we're currently looking at a slide, and you notice it says something about welcome and introduction. And this segment, I'm going to introduce myself a little bit just to give you some idea of why I should be communicating this to you. Now, as many of you know, artificial intelligence is an actual science discipline. And a lot of us are familiar with machine learning. Let me just get a consensus on that. How many of us using the chat window are familiar with the words machine learning? I would suffice it to say everybody here has either heard of machine learning, or you yourself may have been told that someone is using machine learning training, right? And don't forget, if you're interacting, use the Zoom chat. Use the Zoom chat. I prefer that over the Q&A section from Zoom. This way, we're all more comfortable and approachable because we're all providing information that we can all see. So yeah, I think a lot of us hear that. Now, I want everybody to understand, like many other machine learning engineers, I've been in this business for roughly 30 years, since the early 90s. And one of the other things that I have learned during my journey is that whether we are working on, let's say, what some of us might consider as classical or traditional machine learning models, which a lot of us, I think, when you hear things like, I want to predict, right, something, meaning I want to forecast. And if I want to predict something, someone may already make an assumption that we're looking at traditional machine learning that's capable of supporting right? Empowering the very data analytics that you may be using to help your organization, whether you're in the financial sector or in, of course, the health sector and other sectors of business. But you've also heard things of like deep learning, right? When deep learning came out, I think a lot of us, when you heard of deep learning, let me ask, a lot of us may have also thought of, when you hear deep learning, that it's something completely different than machine learning. How many of you may have thought that deep learning is different than machine learning? If you have, use the chat, interact, let us know. And it's okay to say yes, right? Because there's no right or wrong here. This is just your interpretation. Now, during the rise of deep learning, one of the things that I've learned is that we're able to create these very powerful neural network layers. Now, while we're using and talking about deep learning, one would say that we were still using machine learning training strategies with deep learning neural networks. So throughout the years, a lot of machine learning engineers had to adapt and embrace deep learning because we learned that it enhances what machine learning can do using neural networks. Eventually, right, we kept experimenting. Ingenuity and innovation gave way to really powerful neural networks that were able to go as far as taking and improving something that we know, referring to the gradient descent. And through that experience, we learned that we can improve by performing different type of optimizations during the neural network machine learning training. Now, all of this required us to understand how to better improve the machine learning operations. So throughout my experience of 30 years, I've been working on machine learning operations for now running 19 plus years. So machine learning operations isn't new. It's been around for a very long time. Eventually, those same neural networks that you and I know of gave way to greater innovation known as generative adversarial neural networks. Now, when you hear me throw out the word generative, you're probably already thinking about things that you have seen in the last several years. But I'm here to tell you that they've been around for more than a decade. So throughout that experience of machine learning operations, I myself have had to learn how to adopt generative adversarial neural networks. And then that gave way to what a lot of you are probably already familiar with, which is known as the transformer architecture. And for those of you that are new to AI, or you've been using AI recently and all the incredible different services that you've seen released, you may have noticed that they are powered either by generative adversarial neural networks or transformer architectures. And transformer architectures are currently, and I'm sure that this is purely subjective, some of us and our experience is mainly with transformer architectures. But I want you to be aware that machine learning operations is used with generative adversarial neural networks, including transformer architectures. So machine learning operations is crucial for managing the life cycle. And even though we're using words like machine learning operations, it doesn't mean that training a transformer powered AI is different. Interesting. So in order for me to help you better understand that, one would say we would have to go as far as sharing with you what one might consider to say is substantiated evidence. So I want to share with you, and the best way to do that, to start to introduce machine learning operations, as many of you have probably heard, containers play a big part in what we do. So in addition to what you might have heard of with AI solutions, software engineering plays a huge role. So in order for data scientists like David Santana, I also have to know software engineering. So you have to become very well-rounded, and that's where my value add comes. And this is my way of introducing by explaining that in order for me to communicate effectively and drive value today, it's based on my 19 plus years of experience with machine learning operations. And one of the things that I'm using in my environment, which a lot of you will see, are technologies, which I'm going to share with you, that you might need to consider that are going to be a requirement in understanding furthermore that machine learning operations will what? Manage a life cycle of your AI, whether it's a generative adversarial network or whether it's a transformer architecture for a generative AI. And one of the technologies that you see me just bringing to the screen is Linux. And in this Linux instance, I am just making sure that my Docker is running. And I also want to make sure that I have a container that I can use to support some of my requirements. And just to give you a visual, I always like to substantiate just so we get an idea. I'm looking currently at logs from an actual container. And you saw me using Linux to ensure that it was in a healthy status. And I'm going to connect to this particular container. And it is going to be used because I need its kernel to share with you and substantiate evidence and use GitHub Copilot to be able to show you how AI can help you become more efficient in the machine learning operations. I am going to launch an actual tool and show you the tool and explain some of the things that your developers would need to consider utilizing as well. And I'm going to create a new window. And then I'm going to share with you as I connect to the solution. Once I connect, I'll start sharing some of the information that you should consider. So that way it makes more sense. All right, I'm almost ready to share. I'm going to close everything and then I'm going to reopen it so that way you could see from scratch, right, from the beginning. This way you can also understand the processes I had to take and how GitHub Copilot will help in that role. Now, I'm currently sharing something with you, and I want you to see that what I have is an actual integrated development environment tool. And one of the things that I had to do, I'm going to select over here on the left, extensions, and I'm just going to drag this out to the right, just so you could see what has been installed. And one of the things I'm going to type in here is GitHub, so you could see that I'm using GitHub Copilot. Now, there are a lot of, let's call these add-ons, right, which are referred to as extensions, but the one I want you to focus on is the one that is named GitHub Copilot. I'll provide you some additional information on this Copilot. Let's call it for now an agent, on this agent, so that way you can do your own research. But I'm going to go ahead and just restart some of these extensions. I'm going to reload. All right. And while it's reloading and setting itself up, I'm also going to share from my editor one of the files that we're working on. And that is going to be this file here. And I'm going to scroll down, and then later on, we're going to explain some key things on how GitHub Copilot can help us. I'm going to scroll down further, and I'm going to go to this part here, which is going to create our pipeline. And I'm going to just minimize this. I'm going to come back to it because I also want to show you that what I have in that integrated development environment tool, I also want to show you that I'm actually running this in production. And we're going to talk about how in machine learning operations, GitHub Copilot can help us in our data, code, and testing quality, which is part of machine learning operations. And you can already see on the left that we're going to start talking about pipelines. But before we talk about a machine learning operations pipeline, I want to give you some more insight. But I want to show by substantiating evidence that we're not just here merely to provide you concepts that may be buzzwords, but also substantiate evidence in code showing. And I want you to be aware that the actual solution that we're supporting, one moment, is a generative solution, because I think a lot of us, when you hear the word transformer, maybe we don't understand what's in a transformer. So I'm going to explain that and how we're able to fine tune, which is known as transfer learning, for a what? A pre-existing transformer powered embedding model. Okay? All right. A lot of great stuff to come. I know. A lot to wrap your head around. So, GitHub Copilot and its role is going to assist David acting as a developer, not just by merely providing code suggestions, but as an agent, it should be able to do more than just chat. It should be able to help me with different tasks, which will enhance productivity during the coding process. Right. So as long as you're able to understand thus far what my objective is, let me put it to you in simpler words. We are going to understand what is fine tuning to kind of break down that, since a lot of different strategies exist when you hear the words fine tuning, where maybe you think it's mutually exclusive to just retrieval augmented generation. You're going to learn that that is one of the many resources and strategies, not the only exclusive way of fine tuning. But then we need to recognize when we need to fine tune it. I'm sure a lot of us would probably answer, I need to fine tune everything, right? There's a cost that you have to consider. Furthermore, we also need to master techniques, and there are many, used to fine tune. And you have to understand that eventually, while I can explain and I can hope that you visualize, what if you are misinterpreting my communication? This is why there's a hands-on, and you saw just recently that there are several different resources that I will be using to help you and provide practical experience. All right, who's ready? If you're ready for more information and ready to dive in, throw a number 1 in that chat room window. Come on. I need some excitement. Nathaniel's with me. Hey, Nathan, welcome back, my friend. Hey there, Brad. Hey, Cody. Awesome, awesome, awesome. Okay. All right. So, understanding fine tuning. Now, fine tuning is a process, and that process means that it involves taking some existing, let's refer to that as pre-trained. How many of you are familiar with pre-trained models? Anyone? Anyone? I'm assuming yes. We use pre-trained models. And if you're not familiar with the word pre-trained, let me provide some evidence. Keep looking at the screen. If I select a model catalog, notice all these different models, not just OpenAI, but what? Minstrel, Cohere, and more. And these are all pre-trained. So if I choose one of these models, like this pre-trained, what is this pre-trained model's task? All right, let's see if you're paying attention. It reads embedding. Someone in the chat post the word embeddings with an E as an echo for embeddings. So this embedding model, it is a multimodal. So it performs more than one task. It performs text and image generation. Awesome. And this embedding model is also used in search. That's right. And could be what? Used in retrieval augmented generation. And it could be used in things like classifying. An example, if I wanted to classify an image, if I wanted to, ready, understand the sentiment of text, I need to classify it. So this embedding model on the Hugging Face, Oh, so this is a hugging face. Okay. So this is one of many examples of a pre-trained model. It is a pre-trained model. So the majority of these are pre-trained. Now I want to show you, just so that way there is no confusion. If I navigate to another proprietary vendor like Google Cloud, and I go to, in Google Cloud, it's Model Garden, these models are also pre-trained. Okay, so I'm sure you get the gist. The models that you hear most mentioned as large language or as generative are what? Pre-trained models. So fine-tuning involves taking one or more of those pre-trained models and making adjustments to its parameters. Now, I need to make this clear. Are we going to delve into the world of hyperparameters, which are different than automated machine learning parameters? No. But our hyperparameter tuning and automated machine learning operations parameters, yep, different parameters, are they also viewed as fine tuning? Yes. So there's a lot involved in a machine learning operation logical pipeline. But we're going to focus in our fine tuning when we're referring to a pre-trained model and making adjustments, and I use the term parameters loosely, I'm referring to improving its performance on data. One would say that understanding how models learn, which is its data, is crucial to fine-tuning. In other words, before I can consider adjusting, hence fine-tuning hyperparameters or automated machine learning parameters, adjusting and fine-tuning data is key because it is first in a sequence of events. So, what are the benefits and challenges of fine tuning? Well, how many of us have heard of hallucinations? Errors that generative and not exclusive to generative that AI makes because of its probabilistic nature. So fine-tuning does enhance accuracy by refining pre-trained models for specific tasks. For example, how many of you want to adopt AI for your organization as is, and when you do, maybe a business unit doesn't see a return on their investment when you measure the performance, and the metrics of that performance are based on productivity increase in terms of average developer or business unit representative process, where they're able to either decrease their operational time to perform a task, or maybe your metric is based off of how they're able to increase by doubling or quadrupling their efforts. Usually, your leadership wants to see somewhat improvement to a process. So what if they're using these pre-trained models as is? And if it's pre-trained on data that's not specific to your industry and your organization's tasks, then how can that particular AI improve your operations? So one would say that in order for us to see somewhat return on our investments with AI, that fine-tuning should be a business requirement. Now, did you also know that fine-tuning can lead to reduced training time? Why? Because you're not training a model from the beginning. You're probably thinking, David, did you say the beginning? Can you be a little bit more specific? So if I was to say at a high level that your organization would have to start to encourage modern governance before you can start to take data and create a training data set, that would be an example of training a model from scratch. But I am not recommending or requiring you. So, so when David's saying reduce training time, are we talking about being able to reduce the training time of the model because we don't need to start from the beginning? Yes. Now, like any machine learning pipeline for deep learning, whether it's recurrent neural networks or whether it's convolutional neural networks, or again, generative adversarial or transformer, we also have to consider that while you are fine-tuning, there will always be challenges of what? In your fine-tuning, the risks of over and under fitting. That's right. So I am in no shape or form saying that your fine-tuning is so simple that you don't have to concern yourself with over and under fitting your data. And of course, fine-tuning does require substantial resources and time. So there are a lot of strategies out there where organizations are seeking to not require resources that are considered significant based on their budgets. But I have to be candid with you. Like anything, there will always require significant resources. Now, does that mean that when I say significant resources, that startups won't be able to fine tune using what I'm going to share with you in minutes? No, of course not. But I want to make it also clear that fine tuning is not as simple as me connecting to a data source using retrieval augmented generation, where we connect to a data source, and because we're already connected to that data source, that some automated technology is going to then add that source data to an index, and because now it's indexed and searchable, that fine-tuning strategy is done and no more work is involved. I think that there should also be more training, and maybe there's a webinar to come so everyone realizes that there's more involved in retrieval augmented generation than just connecting to a data source using something like Azure's AI search or using Elasticsearch. So whether you're using what I'm about to share with you or using what someone else has mentioned but never truly did a deep dive and substantiate evidence to actually show you, overfitting and underfitting and resources will always be needed whenever you are fine-tuning a model. So because of that, we have to consider when and why to fine-tune. There may be somewhat scenarios where you can use a pre-trained model as is, I would say. How many of you have found some of the pre-trained models to meet your needs without you having to consider fine-tuning? I'll raise my hand. So there may not always require fine-tuning. So let's dig in so we better understand. This way, you can consider if what I'm about to share with you near the end is something that you need to consider in terms of the overall costs. All right. Stay with me. I know that looking at the code, right, keeps you awake because now you're able to focus. While I'm going through these slides, they play a role in understanding. So if you need more coffee, go grab another cup. I'll be right here. I won't go anywhere. So here's some scenarios where fine-tuning is useful. It's particularly useful in transfer learning scenarios where a model trained on one data set requires being adapted to your company's specific task data. Here's an example. In my sales team, my vice president of operations asked me to help my sales team by providing a chat bot that would help our sales team with their tasks. That means I need to consider what data that sales team is using. One, may also factor in that when I use the term sales, you might think that I'm speaking generally. But understand that even if we're in the same industry, your company's business practices and your company's vision of growing your products and services and your business partners and customers, which are your target audience, may be different than another, even if they're in the same industry. So one would say that the data that my sales team uses is data that they're using day to day, which could be and not exclusive to the following. Maybe it's data that they're creating and summarizing using worksheets. No matter the manufacturer or vendor of that worksheet, whether it's a Microsoft Excel worksheet or a Google worksheet, is no different. The data in the worksheets is the difference. However, the data in those worksheets is going to be representative to the tasks, meaning it's going to align with the data that the chat bot would need in order to help my sales team with their sales questions. That's an example of a specific scenario for a business unit like sales that's specific to my organization and their business vision and their data. So, as I start to unpack this, you have to consider that whatever pre-trained data your chatbots are using is not specific to your organization and your business unit. So for my organization and the request made by my VP, it was important that I consider transfer learning. Because what is transfer learning? It's where a model is trained, let me take that word, is pre-trained on data, but needs to be adapted to your data. if you consider the very words I used, transfer learning sounds a lot like fine tuning, doesn't it? Okay. Now, what are the performance enhancements? By fine-tuning pre-trained models, we can significantly enhance performance on what? Not just generally new tasks, but on new tasks that are specific to my company because I'm using my company's data. And the data that my company has, I would argue, is less data than the pre-trained data that I'm sure a lot of you have heard that OpenAI, Google with their Gemini product, Anthropic, and more, right, have trained their pre-trained models on, right? It's significantly less data. What data? The data that I want the pre-trained model to adapt to in comparison to what? A large language model. So the data that I'm going to train the model in, one would say in terms of time efficiency, it's the fine-tuning that I'm referring to saves time by reducing the need to training the models from scratch. So we can frequently take pre-trained models and adapt it to our needs. And that is known as transfer learning. So just in case, what are some reasons for fine-tuning pre-trained models? Leveraging existing knowledge. Where? Existing knowledge that's specific to your organization's tasks. And you're what? Improving it on that niche task. If you consider my words earlier, I said for my sales team, which means I would create a different chatbot for my marketing team. I would create a different chatbot for my leadership. When I say a chatbot, I'm focused on transfer learning, which is fine-tuning on data that's specific to that business unit, to that division, if you will. And remember, fine-tuning pre-trained models saves time. All right. So to better understand fine-tuning and this word or words of transfer learning, let's overview these techniques. Okay. Common fine-tuning techniques include, notice the word layer freezing. Sounds interesting. Which involves keeping a certain layer of a model unchanged during training, allowing, think about it, for newer models that I'm creating to converge faster, and in this convergence, be able to be ready in my machine learning operations for production. There's other techniques, selective fine-tuning, where we can adjust only specific layers of models. Now that word layer, have you noticed a pattern? And then the last but not least, differential learning rates. Now we're referring to changing some of the hyperparameters. Well, I did mention that there are many ways of fine-tuning, not just transfer learning. Okay. So consider some best practices. Appropriate data sets. Let me refer to it this way. The data from my sales team needed to be, ready? It needed to be correlative, or it needed to represent the data used by the sales team. So one would say that I needed data that is representative to the task. So I needed to utilize the right data set. It's essential. Using the wrong data will lead to, of course, slower convergences and, ready, it would impact the output results to the user. Monitoring. Now, while we're only covering transfer learning, which you'll see soon enough, this doesn't mean that your fine-tuning strategies that leverage transfer learning are done once a year. This is something that you need to do regularly. So another thing to consider is, are you using in your machine learning operational pipeline resources that help you monitor end to end, not just on a local developer's environment, but also when that model eventually is registered in a scalable disaster recovery and resilient environment that's used to be able to release your product to market, where in that general release that your chatbot can use this new this new version that is able to help that particular business unit representative with a specific task based on its fine-tuned version data set. So are you using something that provides not just pre, but post monitoring? And remember, while you are fine-tuning, it does go a long way for us to consider that fine-tuning, while you'll find can be done quickly, and that GitHub Copilot will help significantly in order to improve the model's ability to generalize well to new questions from that sales team. It's crucial for us to what? Continue to optimize, which means frequent fine-tuning should be considered. All right. So this is what we've been waiting for, to get a better understanding of a lot of the concepts that you heard me mention earlier. And what that means is I introduced you by talking about how GitHub Copilot plays a significant role and help you understand that machine learning operations isn't new. It's something that encompasses deep learning, generative adversarial neural networks, and transformer architectures, that we need to understand what fine-tuning is, and that it's not mutually exclusive to only retrieval augmented generation, but we also need to consider that the transfer learning technique, that it's not for every scenario. So you need to understand when it should be used and understand that there are, in addition to what you're going to learn today, more than one fine-tuning technique. But in order to, for you to better understand and visualize this, this is where a practical implementation comes in. So thank you, everyone. Get ready. So as I was alluding to at the start of this powerful session, here's a couple of tools that I will be using, but I want to make it abundantly clear that the tools that I'm using and the actual tasks that I'm performing can be done on any integrated development environment tool, on any IDE, or again on a non-integrated development environment tool, as long as you're able to integrate, which is what's vital and key to this webinar, GitHub Copilot. So there's some settings, some extensions, and fine-tuning workflows that I'm going to share with you. And at the end, I'll provide some more insight on some things that you can look into. So that way, whether you're using VS Code or a third-party tool, or you are using other proprietary products from vendors, from Google or Amazon Web Services and more, that what you will see today is something that's well known, that can be implemented with little to no costs for startups and with significant resources, can ultimately bring a return to your investment to transformer architecture powered generative solutions. All right? Okay, here we go. So one of the first things I want to share with you is I'm going to, as I showed you earlier, I was using Linux, and I wanted to make sure that I'm using a Docker container. Now, I'm not here to explain what a Docker container is, but at a high level, so you understand, I need resources that make it convenient for me to be able to package and to be able to take that package and make it portable so I can reproduce what I'm doing on my local machine, right? In any continuous integration and continuous delivery CI CD technology, whether the CI CD technology is one technology or multiple. So using Docker containers is key in AI. All right. Next, I also showed you for additional monitoring that I'm also able to view an actual container that was running. And I wanted to share with you that I can connect to that container, and you'll see me connecting. And when I go into connect, I'm connecting to a resource, and that's within my container. And once I connect to that resource, I'm going to just scroll up a bit so you could see that I have some code here. We'll talk a little bit about this, but I want you to be aware that I am using also get technologies, which means that there is an actual what? Continuous integration, CI, continuous integration with a get version control system. And the reason I want you to be aware of that is because as I'm using that version control system, you have to understand that this is part of machine learning operations. What's part of machine learning operations, you're probably thinking? Well, when I state things like CI, you have to understand in machine learning operations, there is the importance of ensuring reproducible builds and deployments, which means Docker containers is key to what? Reproducibility. And I need get version control for version controlling my code. And I also need a way to what? Take a snapshot, a backup of what I'm doing locally, not just a snapshot of data, as most think when you hear the words backing up or creating a backup of data. I need to register the snapshot of all of my files somewhere. Hopefully somewhere that provides the scalability and the resiliency that I need. So whether I'm using Microsoft Azure or whether I'm using Google Cloud, or whether I'm using Amazon Web Services. I do need something that I can use to provide that level of resiliency. And I need a way to track my model, metadata, and artifacts. And I also need to store most of my code as a script. So I need to script my environments and deployments. And ultimately, what you're seeing here is just Python code. And to give you an understanding, while I have custom Python code that is built for my local environment, it's just to ensure that when I attempt to reproduce my efforts, that anything that is locally cached is not used every time, let me take the word time, every iteration that I want, attempt to improve either my code or my data quality in my machine learning operations. And that's why you see this code here, where it says cache cleared. And ultimately, when I execute that, you can see it says cache cleared. I'm going to clear all of this. And you'll learn as I move forward, which might be something very, very new to some of you, or maybe you were just unaware of it. In most deep learning and what's used in generative adversarial networks and transformer architecture, model development, specifically model development, but not mutually exclusive to it, you may have heard of things like PyTorch and TensorFlow. If you want to, again, do some more research on PyTorch or TensorFlow, most of you are probably familiar with the word tensor from Google. So that's not too far from the truth. And currently what you see me sharing here, which I'm going to clear the cell output, is just me ensuring that I do have a TensorFlow version already installed, and I've imported the TensorFlow package, and I'm using it and ask now the letters TF. Just think of this as a way for me to be able to make my code more concise as a best practice. However, what I want you to be aware of, I'm using TensorFlow. Now, as I mentioned, to help, because in machine learning operations, ensuring reproducible builds, version controlling, registering my snapshot, and tracking my model and scripting my environment is key. And in machine learning operations, validating code, data, and models is important. So first thing I want you to notice, there is it looks like an asterisk, but there are these icons that appear. You might need to just lean forward and look at the screen more closely. But this object shows that there are some actions that I can take because GitHub Copilot is also built in line to the code. And when I select this, we could see that I get a way to be able to optimize the very code that I'm using here, because we could see some options where GitHub Copilot says, do I want to modify or review using Copilot? Let's take a quick review of this. As I selected to review, you're probably wondering, hey, where's that output? Well, the output itself will appear in a chat section. Now, this might start to look very familiar to what most of you may also experience when you're using things like GitHub, when you're using things like chatbots. So if you could see on the left, it says Ask Copilot. And the very code that I selected, I'm going to select again and say Copilot, and then I'm going to select Explain. And now it's going to take that snippet of code, and then it's going to, of course, provide output on the left that's going to tell me that this snippet of Python code demonstrates how to check the version. So now it's providing me a summary of that code. And it is in depth because it's also explaining the first and the second line and how it's assigning the TensorFlow package, which is a library. You might have heard of words like the TensorFlow API. If you've ever heard of that, here's some insight. The term API is used loosely and it's based on your current context. So for all sakes and purposes, I am using a library that allows me to manage the TensorFlow API. Interesting. And I'm assigning that library to what? TF. Excellent. This simplifies usage. And what you'll see below, there's these words of functions and classes. Here's some insight. I love when I read LinkedIn and I see posts from AI specialists and engineers. And I follow a lot of great AI engineers, and I hope that they follow me as well. So as a community, we like to always share our insights to hopefully bring AI to everyone. While AI is for everyone, you must understand that AI in this context, you would need to skill yourself on Python to understand what a function and a class is. So while I can use natural language to ask my questions, the output, which is the response to my query, that output, while it provides information that is legible, the very AI will output information that should be empirical facts if it's not hallucinating, where the words in its output may be something that is not akin to your own skill set. So we always recommend, while you can use AI with natural language to see code and understand it, it does not mean that you should not learn software engineering. So I hope that this is elucidating that you cannot replace your developers because you need to know what a function and a class is. Now in software engineering, just in case you're wondering, if TensorFlow is a library, that means that built in, I could use existing classes that will give me functions that will help me accelerate in terms of transformers and generative model development, instead of me having to use Python without these classes and functions, which could lead to errors that will statistically create more mistakes. So if you do have engineers and they are using PyTorch, or they're using TensorFlow, and they're using GitHub Copilot, I highly recommend that they skill themselves on the Python library so they understand what a class and a function is when they're using it. Okay. So I hope that explains, even though that you're joining me, you still need to consider understanding the output, right? Now, as we move forward, I also have some custom code that I have built in, and I just want to show you. There's a custom code that has a utility script, and I'll show you its purpose. And we're going to use GitHub Copilot to help me in my machine learning operations. So I'm going to go to that file and folder, And here's that utility script. And to give you an idea, you can see that I have imported additional packages that's going to help me with running, targeting for running my workloads, the environment, which is the Docker container images that I want to use, any additional dependencies, which will create that published pipeline that you saw earlier that we'll show you again. And my custom function is actually going to create a what? Virtual machine instance that is going to host my Docker containers, which could be Kubernetes or some managed container orchestrator. And that's what this is showing. So this is what custom code. And that custom code is being used in my script. Okay. And you can see that I'm using Python as an interpreter, but here I've imported that utility. And just to get an understanding of how the utility is going to help us, let's do one more task with GitHub Copilot here. And this time I'm going to right click, go to Copilot, and you can see where it says explain, fix, review, and comment, generate. But I'm going to provide here editor inline chat. Ready? And now I'm going to ask Copilot so we get a better understanding and provide more inline comments. Ready? Now you need to be very specific in your prompt. So specificity is key, I'm sure you've heard, with prompt engineering. So I'm going to ask Copilot, so please include an inline comment document for the Python code in this cell. This is a Jupyter Notebook, Jupyter cell, in case you're wondering. And I'm going to submit that, and I'm going to wait, and Copilot is going to go ahead and provide some inline information. I'm not sure you noticed, but below here, in line, for line 11, import library utility, on the right, in layman's, it says, create a module specification from the file location. 12, right? Create a module based on the specification. 13, add the module to the sys modules. 14, execute. So I asked it in line. So in each line at the end, it added those comments. So I'm going to accept. So notice I was very specific about it adding in line. I could also, on line 2, say Copilot, and I could say generate docs. And when I ask it to generate a doc on that line, it's going to gather some additional information. And remember, this is different than me asking in line. Now, if there are no results, you'll see where it says no results. Please refine your input. So this is reminding you to be more specific. So it's not just assisting me, it's also guiding me whenever I ask a question that it doesn't find that it could provide that would be a solution to my inquiry. But scrolling down below, we can also see that I'm going to be working with a particular workspace. Now I'm going to show you because I'm going to open up a terminal window. And below, I'm using a Linux terminal window. And it shows you that what directory I'm in. Home, David, Project 4. And some previous commands that I have here, I'm also going to make sure that I can connect to my online service that I want to be able to authenticate and authorize with, because I do have already configured an Azure login credential, and I'm going to go ahead and use that now. And as I'm searching by selecting the up arrow for the command, what I can also do is the following. I'm going to go on the left and I can enter, I need to log in to Azure machine learning using, ready? Watch, using a device login. So I can ask for assistance. And you can see how it's running and it's signing in, right, as it attempts to connect. Now it's giving me some more information. And you can see where it's asking me, hey, I want to sign into Azure, where I can either allow it to sign in and use my account, right? Or again, I can use a different account, or I could say, you know what, I don't want to sign in with that. And then below, I could see some information, right, on signing in. I need the Azure CLI command. And you can see that below as I'm running commands to verify that I have a command line tool already installed, I could see some commands are AZ login, use device code. So I could try this. And now to show you here in GitHub Copilot, this time it's going to interact with the terminal window below. All right, so that means below in the terminal, not just in the what? Notebook cell will it interact with. You could see over here the command AZ login use device code. So over here on the right, I'm going to select this insert into terminal. Notice below it what? It sent my text to the terminal window, not to the Jupyter Cell notebook. Now I could say AZ login using device code. All right. Now, as I run that command, it provides me some information, which now I'm going to use to log in. And just to show you the experience, excellent, right? So it's helped me also log in to Azure when earlier you noticed that it was attempting to log me in a different method. So it can help me, right, find workarounds to logging in whenever I'm having issues. And currently below, you could see that as I logged in, now it's going to retrieve where it says the word tenants, different directories that I could be using. Ultimately, what you're going to see is me log in. And then when I log in, this means that because I've logged in, I will be able to go ahead and use Azure. And just to show you, that means with Azure, I'm logged in, and that means I can then configure that workspace. So just to show you here, I'm going to go ahead and we're going to log into Azure. Move this out of the way. And you could see Copilot, and it's still trying to retrieve down there, right? We're waiting for the results. And as it does that, I'm going to go over to the Azure environment. You might remember us signing in here. And this is essentially what I'm connecting to. All right. So it's helping with that process, right? It's trying to retrieve the tenant. And as it does that, it's working to retrieve because I've got many tenants. Once it logs me in, then you're going to see it perform another task. Now, I'm going to stop here for a moment and I'm going to share this with you. And as it connects, all right, as it connects, you could see over here that I have a way to connect. So I could say I want to log in, and right here it's going to retrieve it, right? Because just my login, and it's going to use some built-in credentials. The output of this is going to show the authentication. And it says falling back to using my CLI credentials. Awesome. All right. And then, as it's helping me do that, I'm also going to make sure that I do have compute capacity that I can use. Now, as I go through this process, right, eventually we're creating an environment that's going to support our requirements. Now, to accelerate this, we're going to show you our transformer architecture while that's connecting into the data set, right? So that way it runs in the background. But what I want to share with you is I'm going to scroll up. And as I scroll up, one of the things that I wanted to point out in this code, so I keep going down further, you might see some words like vectorization, but I'm going to scroll down just a bit further. And on this particular page, you'll notice that what I have here, right, is that there is a pre-trained embedding and language model. And I'm going to take some of this information because I want to share this with you so you understand. So I'm going to highlight all of this. And here I'm going to scroll down and I'm going to explain that in a transformer architecture, if you recall, you heard me mention when we were talking about fine-tuning that there are what? Layers. Okay. So if you heard me mention that, one of the things that should have stood out is that if I use the word layers, that means that if I am pre-training, then I'm pre-training something that is referred to as a layer. But because we're using words like transformer architecture, you might believe that a transformer architecture doesn't have layers. Now, I'm going to scroll down because this is the pre-trained embedding model that I'm going to explain that we're going to what? Transfer learn. And what I want to point out is where in line 1, it says encoder and decoder. Okay? All right. So I'm going to scroll down a bit because this might be an eye-opener for everybody so you can see this. There's a lot of information. I'm going to scroll down. And the reason for me doing this is because I want to point out the transformer architecture. Okay? So once I stop at that transformer architecture, I want to talk a little bit about attention so you understand that a transformer architecture, while it is an innovation on top of deep learning, that in a transformer architecture, that we are actually using neural network layers. Okay. So one of the things that I want to share with you as we start showing you how the transfer learning and GitHub Copilot is helping me with what? Documentation, inline, code evaluations. What I want you to see here is that when you consider things like generative pre-trained transformers, GPT, built by OpenAI introduced in June of 2018, and understanding the improvements to language understanding by generative pre-training. That pre-training is a process that involves training a model on large corpuses of text, gigabytes and petabytes of data. And during the pre-training, the model's trained to predict the next word in a sequence given the previous word. That process I mentioned at a very high level is known as language modeling. And after a pre-training, a GPT model, a Hugging Face model, a Cohere model, a Meta, and Anthropic, all of these pre-trained models can be fine-tuned for specific tasks by providing it with smaller task-specific data set. Okay. So understanding that this is all possible then leads you to believe that we can do what? We can take the first step in understanding how GPT works to understand something known as an attention mechanism. You might want to make note of this. An attention mechanism is the mechanism that makes a transformer architecture unique and distinct from traditional recurrent neural networks. That's right. Okay. So that means transformer architectures which are comprised of what? Ready? Encoder and decoders. Someone post that in the chat. Brad, encoder and decoders. That these encoders and decoders, they are essentially layers. And because these layers have multiple attention layers that concatenate the output from your encoder or decoder, it's able to what? Learn complex relationships, everyone. That's right. So the transformer block, while what I'm sharing with you and I'm highlighting consists of an encoder and a decoder, each containing multiple layers of attention and feed forward, ready? Neural network layers. That's right. Layers. Okay. So in that transformer architecture, which again is vital to most generative solutions that you're using, no matter if it's in a chat bot, no matter if you're using it for what? Depending on the what? Multimodal task, text generation, code completion like GitHub Copilot, every transformer architecture notices how the query, which is your input, is passed around a multi-head attention layer that it's added to the output. These connections are common in deep learning. It means we can build very deep neural networks that don't suffer from the gradient descent problem, because these connections provide a gradient-free highway and it allows the network to transfer information forward uninterrupted. But it still has a layer of normalization, which is used in your transformer block to provide stability to the machine learning training process. So a transformer block normalizes each position of each sequence of words in your batch by calculating the normalizing statistics across the channels. It's the complete opposite of batch normalization in terms of how the normalization statistics are calculated. So most, when they hear of transformer architecture, they hear of things like feed forwards, which are, ready? Feed forwards are densely connected layers. That's right. So a transformer block has a densely connected neural network layer. And that component extracts higher level features, which are data. Nice. And this is a Keras implementation. Ready? TensorFlow Keras implementation of a transformer block that you see me displaying here, which consists of an encoder and a decoder. Now, let's take a look at this. GitHub Copilot explained that this script demonstrates the use of a transformer architecture. And the purpose for this one is for what? Where it says sequence modeling. Here's some insight. Transformer architectures are commonly sequence machine learning models. That's right. And whoever your developer is, they specify the maximum length of sequence of the training data set. Remember, I mentioned that we are transfer learning an embedding model? Okay, that's because there's an embedding, ready, model, which has a vector layer. And in this transformer architecture, look at line 6, everybody. Line 6 tells you that there's an embedding size, which is an embedding vector layer. And then that vectorized layer that's used in what we call, ready? A positional embedding layer. All right, now many of you, maybe you've never heard of positional encodings. Anyone? Has anyone heard of positional encodings or positional embeddings? Please be honest. Post the number 0 if you've never heard of that. If you have heard of it, post the number 1 in the chat window. Not many have. All these different buzzwords that I hear about weights and bias, which are based on neural networks, a transformer architecture, and its key function is understanding the encoder and the decoder and actually understanding positional encodings. All right. So a positional encoding is a dense vector that encodes, and this is important, the position of the very words, your text that you're inputting into that chatbot. So that position of that word in a sentence is vital. That position, which is known as a positional encoding, is the final step to understand, because the positional encoding knows, which is what we call the attention, knows about the position of your word, meaning the context of your words based on its position. So positional encoding we use in a transformer block. Instead of only encoding each token using a token embedding. So we encode the position of the token using a positional embedding. Now, if you look, line 7 I've highlighted. That's letting you know that we are using TensorFlow with Keras, and we created a layer for the positional embedding. As I said, because we encode the position of the token, which is using a positional embedding. So that token embedding is created using standard embedding layers to convert each token into a learned vector. Then we create a positional embedding in the same way, using a standard embedding layer. So GPT uses embedding layers to embed the position. Here's some insight. The original transformer paper used trigonomic functions. That's right. All right. So positional what? Embedding layers are important in a transformer architecture because they learn the very position of your words. Now, keep looking at the screen. As I scroll down here, we have a positional embedding layer. Embedding. And as I move over, you could see on the left, if I select line 22, that I have Copilot that can extract the method or modify using Copilot. Or I could use it to review to better understand. So we could see if I move my cursor over it, it's letting me know that I'm using from TensorFlow Keras, a class, the embedding class. And you can see that in that embedding, this is where your input goes. Your input holds the dimensions of your tokens, even your output. So the positional embedding layer plays what? A key, right, task in a transformer architecture. All right. Eventually, the next talks more about the fixed positional encoding. Right? It adds positional encodings to the input. And it goes in to tell you that the positional encoding is in a tensor, right? Saved in a tensor that contains your data. And that we can specify the length of the sequence of the data, the embedding size, and the type of data in that layer. And essentially, this is a custom class where I'm trying to display the image of that positional encoding. I'm going to scroll down a bit so you can see this is very powerful. Then I plot that positional encoding. Look at this, Brad. You might find this, Nathan, to be amazing. Does everybody see this? This is me plotting, and what it's essentially doing is that the token embeddings are added to the positional to give the token a positional encoding. So what we're seeing here is a token and its positional encoding. And this is just a visualization of that very information. So it is essentially the very position of the words from the data set. So a transformer architecture truly understands what? The representation, which is the position of your word. Yeah, I understood, Brad. Got it, Brad. But nevertheless, I want you guys to see this, right? So you understand that the data, understanding the position of the data is key. All right. So another thing to note, the GPT model uses a decoder. Not all transformers use an encoder and a decoder layer, something else to know. But they all use encoder or decoder layers that leverage positional encodings. So I'm going to scroll up a bit and go back to our transfer learning. So I was sharing this with you so we understand that in a transformer architecture, that encoders and decoders, which are key, are using neural network layers. So I'm going to scroll up back to the transfer learning. So now that we understand that there are layers in those pre-trained models, then it will help you better understand that I can take any pre-trained model and I can augment their encoder and decoder. So I'm going to scroll up and go back. I know so much code to look at, right? A lot of good information here, but we're just going to scroll up so that way we could see, right, the transfer learning. Okay. So what I want to show you first, line 30 and line 30. So this way I can give this same code to Brad, to Nathan, to anyone that's listening. I set a random seed, and that number will ensure reproducibility on a particular virtual machine instance or container, whether it's CPU or GPU. Now, on line 31, I want you to be aware that there is a sequential model. As I explained, transformer architectures use sequential API models. And using TensorFlow, interacting with TensorFlow Hub, I'm able to import specific transformer architectures. So I went online to a site and I was able to download a pre-trained universal encoder. Remember, an encoder and decoder are used in what? A transformer architecture. And I chose a specific version. And essentially, I'm reusing a pre-trained embedding large language model, user TensorFlow. And understanding that the model is going to help us where I can use a library to reuse modules, which are what? Models that already exist. So I can what? Reuse pre-trained models for my own purposes. And using the sequential API, I'm able to leverage that universal sentence encoder model. And remember that a transformer architecture, encoder and decoder, uses dense layers. And essentially, all you see here is that I've what? Imported the model. After importing the model, I have added layers. Why? Because those layers I'm going to use to be able to train the model on additional data. Line 37 is me specifying the type of loss function and the optimizer to improve convergence. So to improve the pre-trained model that I've imported, yes, just this command. Look at that, Nathan. tf.curious, hub.curious, and specifying that URL, I'm able to import a pre-trained model. How do I know it's a trainable pre-trained model? Everyone read line 33. Trainable, true. So not all models are set where you can change that parameter. The majority are, in case you're wondering. This information is also available whenever you review the details of any of the pre-trained models. So by setting that to true, I can perform what's known as transfer learning. Suffice it to say, I've added these additional layers so that way I can do what? Fit the model with more training data. So that doesn't mean that I'm going to train it on its pre-trained data. I'm going to train it on additional data that I've added and that I want to validate and how many times I want to train it. And in addition to this, I need to do what? I need to add data that's specific to my task. So then I downloaded a data set. You can download using Python any data set. I've used, even here, using GitHub Copilot, I've used a Google API with GitHub Copilot to download data that's a Spanish and English dictionary. For what? For Spanish and English translation and sentiment analysis. And I added that data. So this is the what? Task-specific data that I'm adding in my transfer learning. And then I stored that data. And to better manage data, you may have heard of things like NumPy. Why? Because I need to split the data, but I also need to what? Perform some data science feature engineering, right? To ensure that the data is quality. Eventually, now what you could see here, then I start to configure a way to what? Text vectorize the data set that I've added. While the pre-trained model already has undergone this type of training, understand that the new data hasn't. So I configure a text vectorization layer. This script sets up the vectorization for that English and Spanish sentences. And ultimately, the text vectorization layer converts the text into integer sequences. Remember that our transformer architecture works on what? Sequential information. And we are using a sequential API. And for that vectorization layer, we added the vocabulary size by specifying the size of the data, the maximum length of the sequences. So that way, if I am going to train our pre-trained model on the new data, I need to control the maximum length of data based on how much my local machine can handle. This is why it's important to do what? Eventually scale out and use Microsoft Azure AI Machine Learning Studio to do what? To handle, right? Augmenting the small data set and what? Creating or what? Reproducing or augmenting more data and then what? Training it on what? Powerful NVIDIA powered systems where I can again ensure that now I can use the power of NVIDIA GPUs to perform in parallel or in what sequential processing of that data. And in machine learning operations, I can use GitHub Copilot to help me better understand these unit tests. And even the code that was being used. And as I copy this, I can go back to GitHub Copilot to get more information to better understand how my unit tests and machine learning operations are also being used in that pipeline that I created that is also automatically going to be what? Automatically triggered when I start to make any changes because of my machine learning operations, continuous integration, where any changes to my existing Jupyter Notebook cell code would automatically trigger what CI pipeline to start this process and perform another unit test on any nuances to the data. So let's get a better understanding of this unit test by using, of course, GitHub Copilot. Go to my chat. There it is. Can you please explain the following code? And as I ask GitHub to assist me, it's going to start working. And let's see what it tells me about this unit test. Now notice in my machine learning operations, not only have I asked GitHub Copilot to further assist me with adding inline comments to better assist during the process of operations, but also now I'm not only asking it to help me with the code in the cells, I'm also asking it to assist me with the unit test. And let's see what it reads. It says that the code defines a custom callback class for unit tests, specifically designed to log test results in Azure Machine Learning. So the unit test imports a module which is built in for creating and running unit tests. The unit test class inherits, and it says there's a constructor. Let's get some more insights. So it goes on to tell me that in line 4, this is very important, there is a method that's called when a test passes. It first calls something called add success method to handle the success events. Then it logs the success to Azure Machine Learning Run in a log method. So what is it doing? Let me scroll down a little bit further, because it has a lot of these methods that I can essentially determine are being logged. Are these unit tests used to detect data bias or lack of data quality? Let's say lack of data distribution. So we can get a better understanding overall. Okay, this one's just, it says designed to detect data bias or lack of data distribution. They're not specific to, instead, they're general purpose unit tests that log the results, failure areas, and skip tests. So now I can ask it, can you use this test to detect bias? And if so, can you generate a code example that I can use in my unit test? So now that we get a better understanding that it's just a general unit test, we can ask it to take the current code to give us some insight on how we can use that to better detect bias. So it says, yes, we can create unit tests to detect bias by implementing specific checks for bias-related issues in your data. Excellent. So it's also telling me what I need to install, and it gives me an example of how to use those same tests, which are looking for imbalances. Awesome. Great. Excellent. And it also adds, notice it shows you can integrate this unit test with the Azure ML unit test callback to log the results. So it's letting me know how I can use this in conjunction with the general callback class that I created. So now it provides a working example. Hey, let's ask it to adhere to machine learning operations best practices. Can you update the preceding output to adhere to MLOps best practices? And as you can tell, as I continue to interact with GitHub Copilot, it's not just giving me comments. It's not only helping me be able to log in, right, with the terminal. It's also assisting me to be able to analyze current machine learning operation unit tests. And then it goes as far as providing me a comprehensive solution that I can use with my current unit tests that I can actually run in production. Furthermore, now it's also going to help me adhere to machine learning operation best practices. So as I scroll down below, we'll see what it did further. Import unit test collections, loading my data set, and then furthermore, and to text for data bias. And then it gets the context of that unit test. And to find out more information, I could see some of the explanations of the changes. This function is responsible for loading and pre-processing the data. This class test data bias contains a unit test for detecting class imbalance and the integration with my Azure Machine Learning. So it provides not just snippets of code that I have to consider how to refactor, it provides holistic solutions on demand. Okay. And one last thing that will probably wrap up our session here, I'm sure you're going to have lots of questions, is going back here as I continue to explain that fine-tuning known as transfer learning is possible. So furthermore, as I scroll down here, right, I was explaining the text vectorization layer, and you get the idea that there's data that this text vectorization layer is going to work with. But we should also consider, right, adding this to our pipeline, and in that machine learning operations pipeline, which you saw me share with you, that's available in Azure AI's Machine Learning Studio, that we should and have the capability with GitHub Copilot to actually assist me in performing those unit tests. And as I scroll down further, we can see the text vectorization layer retrieve the data set, and it's vectorized the data. And as it vectorizes those tokens, it's what? Tokenizing. Thinking it. V-I-2-U top. So it's vectorized the words, and we're just getting the vocabulary so that way I can share those results. So the text vectorization layer worked for the additional data. And I was able to what? Verify that by seeing the output. And now I take the training and validation data set, and what this means is I take the data and I add that validation data set, and that data set is in our tensor flow, which means it's stored in a tensor, and each tensor contains hundreds of thousands of sentences for training. Pretty cool, right? And we have our what? Training and validation data sets. That is our what? Task-specific data that we're using in our transfer learning, which is known as fine-tuning. And now you could see on line 17, 18, 19, and 20, let's take this code to get a better understanding. Of what's going on. Right? To get a better understanding of what's going on as I use GitHub Copilot to give you a better visual. You could see on the left it working, right? So we have a better understanding of code that's this, right, granular. And it tells you it's preparing a training and validation data sets. As I mentioned, for that what? Sequential model. And then it provides a summary. Okay, excellent. And while we're looking at that, as we keep going further down, we could see here, there's our encoder and decoder. So the encoder and decoder is going to be configured to handle you and your inputs. So imagine a chatbot. Imagine a built-in embedded AI agent. So this is going to end up handling any of your inputs, and it's going to also, in its encoder and decoder, handle inputs to provide that output. So it's taking our training data that's added to what? A layer. And then the encoder and decoder, let's see what it does. All right. It takes what? The embedding information for the embedded vectors, and the encoder and decoder the input IDs for all of your encoded data that's obtained from that vectorization layer for what? The text, which is the data that we're training on. Ultimately, right, this encoder and decoder, as we could see here, and let's find out and summarize, right? Watch me grab this embedding layer. And I'm going to ask Copilot to help us. Can you provide in simple words what the following code is doing? Now we're going to wait for its response. So embedding size. So notice it's letting you know that's the what? The vector, the embedding size vector. Those represent the words in that vector space, in that position. Remember the positional encoding? All right. And then we convert the text to IDs. Then it tells you that the encoder inputs your IDs. What? It converts English text or Spanish to what? Encoder IDs. And then that's added in a layer. And this creates that embedding layer for the encoder with your what? With your data, your vocabulary. And ultimately, right, it sets up the embedding layers for both the encoder and decoder parts of the neural network model. It converts it into what? Numerical IDs, and then it generates embeddings. And these embeddings are what? Representations of your words. Amazing. I love this stuff. It's amazing that GitHub Copilot is not only able to help you with your code, it explains each granular and significant critical piece of what's going on in the process of transfer learning. Ultimately, to ensure that our model does not forget, we create a long short-term memory for those encoder and decoders. Let me scroll down further. And essentially, our encoder and decoder model, we then train it. You could see the beginning, epoch 1, all the way down, and the accuracy gets better while the loss gets worse. Accuracy started at 0.42, everybody. And then ultimately it ended here, which we could do better, at 0.83. And it has a loss of, again, 0.2. So essentially, right, every epoch, every time that we trained it, the accuracy got better. And as we scroll down, then we use that particular model to predict. So I tested it out here to translate, because I can test out the model. So ultimately, what we have learned so far is that GitHub Copilot is able to help us in terms of machine learning operations with this pipeline task, where we're able to not only execute cells of code, better understand the very code that we're using, even if it's custom classes, help me find a workaround for logging in to online services, help me also be able to inline understand how we're able to use code to basically create a training cluster remote. And now that we have that environment, we can essentially use, right? We can use this to even support us whenever we get errors. So last but not least, as we're attempting to connect, we can also use it to fix. And I hope that everybody has enjoyed this. And you can see here, it's generating some edits and it's letting me know what I need to do. To fix this, you need to ensure the get run config function is correctly defined in the utils model. Since the util model is loaded from a specific path, you should verify that get run config function is defined. So it's letting me know what I need to do to ultimately fix this. And by where it says the utility Python, I know if I scroll back up here, they're referring to this and that import of this particular utils Python. So they're talking about this here. So this is being used in that utils Python. And ultimately, it's letting me know that I need to check this file. Awesome. All right. And essentially, I can have GitHub Copilot review this. One last thing. Select Copilot, add selection to chat, review the code. And when it's done, I can ask it to help me mitigate any problems with the code itself. And there is that get environment and get run config that it's referring to on line 23. Excellent. All right. So I hope everyone's enjoyed watching Copilot not just provide inline comments during the machine learning operations process, but ultimately for powerful transformer architectures. You learned firsthand in this demonstration that ultimately it can help me once I utilize GitHub Copilot as an extension in my fine-tuning workflows, not just in asking GitHub Copilot a question on code itself, but ultimately it helped me from my Jupyter Code cell to my Docker container terminal, command line login commands, to multiple Visual Studio Code IDE syntax to better understand the actual code, to simplify understanding its purpose, and to help me with in machine learning operations unit tests, which are critical, not just for performance, but as you can see, I can use those for detecting bias, which is ultimately important for responsible AI to drive fairness. I threw that in as a value add. And I hope that everyone has also learned through this all too brief demonstration that while GitHub Copilot is powerful, I still needed to have a skill in software engineering with Python and with artificial intelligence, and as in-depth with machine learning model training, which encompasses not just classical or deep learning recurrent or convolutional neural networks for vision, but also for generative adversarial networks and for transformer architectures. So I hope everyone enjoyed this free webinar, and I'm sure you've got a lot of questions. I hope to see a lot of those questions in LinkedIn, but we do need to wrap up this session. I think I've gone a little bit above the time constraints, but I wanted to show you how I can use GitHub Copilot to enhance the way I work as someone who is part of AI for everyone. All right, so if you liked what I demonstrated and you love this free webinar, please let us know. Let us know. Are there any questions that you might have? All right. You're welcome, Cody. I hope you guys did enjoy. All right, there's a lot of moving parts there. I always recommend if this is the first time you've seen AI at this granular level, and maybe to you, this is not what you were explained, or maybe you didn't quite understand, I highly recommend following me on LinkedIn. Follow me on LinkedIn so I can shed light and provide explainability. So that way everyone can improve the way they work, which is the objective of AI for everyone. Of course, Brad, that is important for us to learn how to interact with Hugging Face, with Anthropic, with Meta, not just with OpenAI. So please, thank you guys. I hope everyone enjoyed. You're welcome. So let me see if Anna's back. Anna, are you back? So open floor for any questions in case anyone has any. No? If there aren't any more questions, let me check on Anna. Hopefully she's there. Hope she's okay. Let me check. Anna, can you hear me? I know
Yes, I'm
earlier.
here.
Oh, there. Oh, you are there. Okay. Awesome. We're wrapping up. Yes, that is exactly why Anna's joining us. Yes. So there's some questions about related courses and certifications from Krupa. Anything that you want to share there, Carol? Anything that's coming up?
For the last slides, we do have. Hey,
Yes.
so thank you all for joining and staying with us today. Thank you, David, for another amazing sessions. So I want to invite you all for our free Microsoft Copilot trainings that are coming up. We are doing March 31, the Copilot Foundations, April 7, Empower Your Workforce with Copilot for Microsoft 365, then Craft Effective Prompts for Microsoft Copilot. That is very, very good. I already saw these classes, all of them. In April 21st, Microsoft 365 Copilot User Enablement, okay? Those are not foundational classes, just the March 31. So, and you are not find these courses for free. So join us. You can enroll at our website. And we also have a promotion that is our Copilot workshops. So for $1,100 up for 50 people, you can attend these workshops that include demos and the Copilot 365 for productivity, also to know more about prompt engineering and why we should be aware of AI, okay? Please join us. If you have any questions, feel free to reach out to us, and thank you again.
If you like this video, don't forget to subscribe and click on the notification icon to get notified whenever we upload new content.